Hi, Luis and Juan. Just want to wait a few minutes so the attendees can start coming in. So we have as many attendees as possible before we launch this session. I see a lot of people were in the waiting room, so this is exciting. Another minute and I'll start this. Hello, everyone. Thank you so much for joining us today for our webinar around 3D printing and design. My name is Jude Hamoud. I'm the head of business development for the Sharjah Research Technology and Innovation Park. I wanted to thank you all for being here with us today and wanted to take just 2 minutes to give you a quick brief about our science park. The Sharjah Research and Innovation Park is a science park that we set up and inaugurated just last week with His Highness Sheikh Dr. Sultan bin Mohammed Al Qasimi. He's actually our chairman, and we are a product of AUS, which is the American University of Sharjah. We are set up to accomplish a few missions. The first one being building an innovation ecosystem. So what essentially that means is attracting like-minded entrepreneurs and innovators. We're stage agnostic. We work with all sorts of companies from very early stage to Fortune 500 to really get them to collaborate, innovate, spin-off ventures, all focused on tech. The other mission is to, of course, generate employment. We are also very much engaged in catalyzing knowledge economy through our events, through workshops, trainings, and research. And last but not least, invest in the future. So everything that we do has a socioeconomic impact to it, which is also why we're focused on these particular sectors. So we focus on technologies such as environmental technologies, renewables, digitization, mobility, logistics, smart cities, production, design, architecture, and water technologies. Very quickly so far, we've been working on the park for 4 years, but we've only launched 6 months ago. And since then, we have 6 anchor projects. So in our own campus, we've got actually 1.8 square kilometer space where we've got our headquarters and big scale pilots happening in photovoltaics, agri-tech, we have concrete printing, additive manufacturing, AR, VR, and transportation with Skyway. We are also adjacent to the university city, which means we've got access to a lot of talent, including 47,000 students, over 200 universities, and 2,000 PhDs. This is the master plan. It gives you a little bit of idea of the scale of the project. This is our headquarters over here. We've got 3 kilometers of Skyway doing 3 kilometer testing and certification projects for the next generation of floating trains. We've got a maker space, and you see a little bit of the companies that are associated with us and that are testing on the ground. Specifically related to this webinar, we do have one of the region's largest manufacturing hub construction metal and plastics. So we do that through our makerspace, which is Soy Lab. We do that as well with a company called Meet that is focused on 3D printing in the construction area. Of course, Acciona, Lewis is here with us as well, and Immensa for advanced industries, focusing on printing metals and plastics. Last but not least, a little bit more about Soy Lab. We've got a 2-floor makerspace that is focused on rapid prototyping. We have all sorts of machines applied to wood, metal, plastic, even textile. We will be hosting workshops and events, and they will be open particularly to our members. Without further notice, I'd like to also introduce our participants and panelists today. We've got Luis Rodolfo Clemente Ortega. He's the COO of Acciona. Thank you so much, Luis, for being with us today, as well as Juan Roldan. He's the Associate Professor, College of Architecture, Arts and Design at the American University of Sharjah. I'd like Juan to take the lead on telling you a little bit more about what they do in the College of Design and Architecture, and particularly applied to 3D printing.
Thank you very much, Jude, for the invitation. Thanks to the Research and Innovation Park for opening and organizing these panel discussions that I think it's an excellent way of networking and to research on possible collaborations in the present and in the coming future. Particularly from our perspective, the way we teach, or the main motto of our educational model at AUS, and mainly in the College of Architecture and Interior Design, it's designing and learning through making. So it's an ancient motto and a motivation from many schools of architecture. If we think about the Bauhaus, okay, in the early 20th century. But I think it has really reached a tipping point in this new century, thanks to digital fabrication. We are conscious about the issues and the potential implications of great benefits that these kind of new technologies imply and can be, how can be embedded within our educational models. But we really think that the perspective that we as educators have and students have through making things with their own hands and going through the trouble of dealing with a fabrication process, it really changes absolutely the perspective of how they will designing in the future. Knowing, as we like to say, knowing the weight of things, is an important aspect of how to design a building or a chair in the future. I'm going to go very briefly, quite quickly, with a short presentation that I have prepared. In this case, it's more of an academic approach. I didn't want to clash with anything that had to do with real fabrication of the masters and the real leaders in that technology, like the example of Acciona, that I think they're making an excellent job in that sense. And it's more about how 3D printing becomes a tool for speculation and can take us to construction. There's a new paradigm in 3D printing in general and digital fabrication. I want to open it a little bit more into the broader spectrum, because I think that there's always an interesting thing when we don't have airtight conditions. And it's this idea of in vitro versus in vivo. Okay, so when we think about how certain experiments happen in the laboratory from a chemical and chemistry point of view, there's this obsession of, okay, we do something that it's happening in a small glass tube, and then probably we can expand it to a larger scale. This is how it's really working at this point, and will be some of the examples that we will be seeing in my short lecture. And it has to do with that obsession and that potential amazing feature that we have nowadays, is that we're not just doing work of simulation, but we're moving into a work where whatever we're designing can be produced and can be a final finishing product, full scale, one-to-one. So when we think about designing process, and again, any tool like a 3D printing or any digital process is like having a microwave, okay? So we can limit ourselves, okay, to use it just to warm up or to heat up our tea or a mug, or maybe we can find the potential, or maybe dream that we can really explore how far we can take it, and maybe think that we actually can cook a beef Wellington with a microwave oven, and this is something that at least we have to try. Okay, at least probably we have to throw the sun a little bit far to really think how we can stretch the limits of the technology, so in order to move forward. And we've seen a lot of examples in academia where actually a laser cutter is used the same way that you will be using a cutter. So I mean that is a change in the way of the way we think and the way we have to make our students think of how to use the technology in their advantage. When we think about design thinking process, and it's something that has not happening lately within architecture or interior design disciplines, I really like the approach that this discipline has to do with this idea of prototyping. That whenever we have that, whether it's one of these three parts of the design thinking: inspiration, ideation, of implementation, there's always an element of prototyping in the center, but there's always this process of back and forth, okay, of revision of a low resolution prototype, and how it can be really observed, understood, tested, okay, and then how that prototype can evolve into a final prototyping after before the implementation. And again, happens with the diagrams of research synthesis, ideation, and implementation, okay, the DDDD diagrams that it's commonly used within design thinking. And again, it allows us to really go beyond the technology and think much further. Lately, I've had the pleasure of curating a festival of architecture in Dubai, the first RIBA Gulf in association with Dubai Design District Architecture Festival. And it has been an interesting element to really think and to really observe how these technologies are being used. We have, of course, the final representation of a model, meaning that some of these models really try to replicate what the final conclusion of that model is, okay, like we have in these cases. So it's this starch, what we call layer or powder prototyping. That kind of technology I will allow Luis to really talk more, because he's an expert in that sense. But at the same time, we have realized that there are many other 3D printing elements that has to do with exploration, with the speculation. So I think that really opens a wider window into the future, and it allows us to really think about how the future could look like. And again, it allows us to really have a very fast way of testing many iterations that with analog techniques would be impossible. When we think about and when we think with our students, which is a kind of formal response or final language that they're exploring when they're doing architecture, or we're doing interior design, or we're designing furniture, is very important to really analyze what kind of language you're using to really begin to see which is a kind of technology that can accommodate the process in order to move forward, in order to move faster, in order to really, as we were saying in those diagrams that have to do with these diamonds, in order to explore more iterations, to then narrow down to those solutions into the final one, hopefully. We've seen that, and in this case, and it's probably the most interesting part of the exhibition, was how we invited many of these practices to really introduce not just the final models, but some of their process model prototyping that were probably, in my opinion, almost as important as a final product to really analyze and to really understand how the process had evolved. Okay, I would say from an intellectual point of view, but also from a formal and production point of view. Okay, in this case, this is what it's hopefully will be bridge building of infrastructure over Sheikh Zayed Road that will allow a big stretch of the road to become pedestrian, become a garden, become public infrastructure when having all the traffic going underneath. That I think is a very interesting way of exploring these geometries through certain parametric architecture and parametric software that otherwise would be absolutely impossible to do if we think about a handcraft product. This final process, some of the installations that in this case the studio was exploring to really do at a full scale, human scale size in D3 that was a little bit more stretch toward the vertical. But when I think about 3D printing, or we're thinking about the technology, again, I don't think we can understand it, or we shouldn't be framing it as an airtight condition. And I think that I've been privileged enough to really be invited to certain amount of reviews at UCL, the Bartlett School of Architecture, to be part of the reviews of the Master in Biotechnology Integrated Designs that is co-directed by an architect and a biochemistry engineer. And the most interesting thing about this specific Master, it has a high level of speculation when we think about that these students are growing bacteria, algae, certain types of control viruses, etc. But all these kind of chemistry really needs infrastructure to live in. Okay, many of the experiments that these students and some of the faculty were conducting, and I have to say that it was more than a year ago, had to do with how they were 3D printing certain proteins or certain chemicals so they were really reproducing the structure of wood, what we're using lignum, by accommodating and by understanding the sequence of the growth of those proteins and those elements. They are beginning to analyze how that element can grow. Okay, and even in this case, Professor Martin Date Robertson shows one of the first examples where actually they were growing real, let's say, marble, but done artificially, but with the same characteristics of real marble. So when I think about that kind of experiments, I think they opens this interesting understanding of that hybrid education and hybrid discipline, interdisciplinary crossover, where in this specific case, they really analyze the 3D printing through different proteins or all the different kind of organic materials as a scaffolding for all this growth and organic growth of certain algae, for instance. Some of the most groundbreaking examples have to do with understanding of this full-scale tilings and even facades, like in this case, where all these organic materials are actually beginning to grow within that scaffolding of the 3D printed, and actually are allowing the atmosphere to really reduce the CO2, okay, at absolutely stunning levels. That I think it's a very interesting element. Some of the examples that they have been allowing to weather in the outdoor conditions of the UCL, University College London, just to study all these different levels of humidity, the different levels of how these 3D panels can really absorb and to keep certain amount of moist to allow the other organisms to grow. Okay, and I think it's a new paradigm that I think it's gonna be the most important shift in architectural design and architectural education in the coming, I would say, hopefully less than 10 years. But that has to do with that important aspect of really how from academia, some of these processes are really being pushed forward into a level or a scale, as we were saying before, this in vivo scale. I will leave it there, okay, and then I will just allow Luis to go ahead and then probably have discussion and question and answers. Thank you very much indeed.
Thank you so much, Juan, for this. Super interesting. In my mind, I was stuck on a complete different aspect of the design, but I'm really keen on talking about that a little bit more later. Luis, would you do you have a presentation you'd like to share your screen?
Sure, 1 second.
Wonderful.
Okay. So thank you again for the opportunity to be here with the SRTI Park. It's always nice to share with so many people interested in technology and innovation. Juan, muchas gracias por la introducción, por dejarlo allí. Has dejado el listón alto. Very good presentation from Juan. And I will try to take this baton and continue a little bit, bringing this idea of how in academia and in laboratory scale, we can also be talking right now about real cases and large scale and even one-to-one solutions. So I will give you a brief introduction about Acciona, and I will talk about 3D printing in general, a revolution. We will see how it matches, from my point of view, the design world, and we will see some applications so you can have a better idea of what we are talking about. So when it comes to Acciona, Acciona is a Spanish company that works in infrastructure solutions and renewable energies, headquarters in Madrid, almost 40,000 employees, really intensive in R&D, and the fact that I'm here today talking about 3D printing is part of this idea of pushing innovation and R&D. And we are also carbon neutral since 2016, just showing our sustainability commitment, among other activities. We have very well presence also in the region, which is one of the reasons why we finally installed here our 3D printing facility. So I said it was meant to be brief. I don't want to make it so when we talk about 3D printing, I like to talk about a revolution. Okay, although the 3D printing, additive manufacturing has been in the ambience for more than 30 years. It wasn't only about 10, 12 years ago that it started to come mainstream, but everything in the very small scale for rapid prototyping, it wasn't really for final object or applications, but only in these last 10, 12 years, it has evolved in a way that it became a real revolution. Every single manufacturing sector is going to be affected somehow by 3D printing. You can think of the automotive industry. Nowadays, so many cars are including 3D printed pieces as final pieces, I mean, real use, not only prototyping, not to mention all the tools that they have created to improve the production process. Same happens in the aerospace. So many companies already saving weight in the planes, that it's every kilo in a plane counts, and they would do anything just to save, to make it lighter. In the medical sector, Juan already mentioned something related, electronics. Every single manufacturing sector is going to be affected, and it depends how they embrace this change, this revolution, if it's going to be a positive change, or if usually if you try to stop it, most probably it's going to be a negative for the sector. So, and construction, of course, is not an exception for this. So if we talk about construction, it has been evolving. From a revolution that is 3D printing, now let's talk about the evolution of the construction. It took millennia to go from the traditional like pyramids or temples so many years ago to reach certain level of automation and more industrial ways of building. And from that point, only a few decades to reach a digitization era that where BIM, drones, autonomous vehicles, VR, AR, 3D scanning, 3D printing, all these technologies just coming together at the same time, and they are speeding up, pushing the evolution in the construction sector, even when the construction is one of the less digitized sectors of the industries. So it has happened in a few years. So what's going to be in the next year? It's hard to tell, but we have to be prepared, and we have to work on all these new technologies just to keep pushing and keep improving. So apart from the evolution on the construction, I see in the design area, which is the matter today, that the technology is bringing some augmentation, is helping, is making the designers to have more tools and to reach much more solutions. One commented that to make it broader solutions than to go back to the final right. But this making broader, having more options, I think this is key to get the right final design or object. So that's what I'm saying. We have an augmentation from a designer on a just with a paper. They keep using it, of course, but before, at some point, when it was just pen and paper, then it got the help from computers and CAD software, and it changed a lot the way they produce and the quantity, the amount of material they could produce. They could share, they could make it faster. The computer gave to the designers a big tool to work more and better. And nowadays, the next step is the artificial intelligence. Is even given the designers one more push to find a better solution for any issue in terms of designing. Artificial intelligence is there to help them. So what I want to say, what I mean to say is that we have nowadays new design tools such as topological optimization, parametric design, yeah, this kind of new tools, design tools. But we also have new production processes, meaning 3D printing, for example. So what happens? They both, they help each other. I think they make a perfect match. Because if you think of this new kind of tools like topological optimization, if you get any design through the computer and the software, you get the optimized object. Usually, it imitates nature forms. So if you get that result to produce, it's going to be rather complex. They are not usually just a square and just as you can think. So you need a specific or more advanced production process to make this design real. So if you don't have the process, why should you design in that way if you are not going to be able to produce? Or what are you going to do with this very nice production process of 3D printing if you don't have the capabilities to design and take advantage of the process? So this is what I'm talking about, design augmentation. So my message here is just designers should also keep in mind 3D printing as one more option for designing and producing. So just going in my expertise area, I want to make a quick stop here talking about the main technology available for large-scale concrete 3D printing. From in one side, we have the powder bed type technology that it takes, if you are familiar with a smaller scale, maybe it's like powder fusion or binder jetting, we spread a 5mm layer of dry mortar, and there is a printing head that is going to apply the ink or the liquid only in that area we want the concrete to harden. So we are going to print any digital object in layers or horizontal layers, adding layer over layer. So this is the system that we have installed here that is based in the D-shape technology. And the other system also for concrete 3D printing is extrusion, where you have one nozzle that is going to extrude the mortar and putting also layer over layer. And this nozzle can be moved by any means in the three-dimensional space. You can have it with a robotic arm, with a gantry system, with a telescopic crane. There are cable systems, there are many ways to move, but as long as you can move it in a three-dimensional space, then you have the extrusion in general system. These are the two main technologies. Nowadays, here in Dubai, we are producing with the D-shape technology, and we are just bringing the contour crafting soon. We're already working in innovation. So just applications and quick images of things that we have already done or some projects. This is the first concrete 3D printed bridge of the world. It's in Madrid. We installed in December 2016. It's a 12-meter long bridge, sorry. And it's printed in 8 segments because we printed that with a smaller printer of 2 by 2 by 2 meters. So we had to cut it in pieces. And this kind of segments, then we joined all together and we installed as it was a precast element. This is a generative design case. We worked with Autodesk and we printed we designed this staircase with the generative design tool from Autodesk. So this is what I was mentioning. If you give, okay, you give the constraints to the software and you say, I need the steps here, I have this printing volume, and the software is going to give you thousands of solutions, they are mostly going to be this kind of if you give completely freedom, the optimization will give you this kind of biomagnetic shape. So if you don't have a process to produce this kind of thing, so you have nothing. You will have to go for a more traditional design in any case. This is a project here for RTA that it's a 50-meter columns set that and 3 by 3 meter section. If this is finally done, it's going to be the biggest 3D printed thing on the world. It's going to be huge. Here, our idea was also a modular approach, segments that we stack one on top of the other, and just to create and give this, thanks to the 3D printing, we will give this kind of rock texture on the surface. This is a concept idea. Inspiration is everywhere. This is a spine bridge that maybe we can, thanks to the 3D printing freedom of shape for designing, we can get inspiration in nature. Some other projects in terms of, those are all more in like structural ways, in singular structure. We work also with urban furniture, like these cases. These are a few benches that we deliver here in Dubai. This is one bus station. We also prepared here, but this is for Ashman. Here we have a combination of material. We have the 3D printed concrete. Wherever it adds value, and we have some steel columns, for example, because it makes more sense to work on steel on that way. This is a few more examples. This one is at this moment is in the 3D printing exhibition in the park. You are all invited to come and see. This is going to be this piece there. One more example for kind of urban furniture. This is a planter. One more application is about sculptures and working with heritage, cultural heritage pieces like architectural or sculptural pieces. We work with the Archaeological Museum in Madrid, and we made an exact replica. The original is on the left on your screen, and the copy is on the right. In this particular project, we printed in concrete in 3 pieces, and then we joined together. But of course, there is an artist that is going to be the final touch, giving the final color or the small details. Whenever we don't have enough resolution to reach, then you will have to give this final detail. This is a replica of José del Madroño. It's a very famous sculpture. It's in the emblem of the city of Madrid. And this replica is now in Mexico City, in Guadalajara, sorry, Mexico. We had to make a copy of the digital scan of the original, and then we replied. This is pretty much what I want to say for a moment. I didn't want to take too much time, but that doesn't mention the message. Let's enter to a new era for design technology. Thank you.
Thank you so much, Luis. This is fascinating. It's very cool that we're also able to replicate things that are no longer, that pieces of arts or even replicating perhaps things that are no longer existing. I'm kind of thinking about, old castles or citadels or old statues, being able to, should we have the digital twin of it, replicate that somewhere else is really interesting. Thinking about all the monuments gone.
There is a technique to create 3D models that is called photogrammetry. And there's a software that based only on 2D pictures, it creates the 3-dimensional model. Of course, you need a lot of pictures, but it happens that any famous place that, I don't know, think of Michelangelo's David. You know, that sculpture, I don't know how many pictures there must be around in the world. Think of that, the Michelangelo, the David is destroyed or disappeared. If you want to replicate, you can collect all these pictures from everyone. And if you put it together, some extra work, then you can create the exact three-dimensional model of that piece. And then you can replicate. That's the kind of things that you mentioned. This is
absolutely very, very cool. It's very clear that, I mean, you are both representatives of two elements that are completely necessary to move this forward, right? A question that I'd like to ask Juan is sort of how is 3D printing, how has it influenced teaching design and training the next generations of designers and architects, and how difficult is it to do that given the fast-paced sort of the transformation of 3D printing itself, the new materials, the new techniques, the new machines?
Yeah.
How do you deal with that from a curricular standpoint and from the training standpoint?
Yeah, I think it's like something that is running in parallel to our academic world. It's always really difficult to keep the pace with it. Sometimes academia is ahead, sometimes it's behind. But there's always, at least we try our best to really get refreshed, to really have access to this technology. I have to say that we are privileged here at the College of Architecture and Design at the US because of the technology that we have. Not just because I think it could be easy to have toys, but without the knowledge or without the curiosity that I think at the end of the day is what is driving any of us to really know more about what you can do with them is actually the driving force for anything. Curiosity that has to do with creativity is one of the important elements. How it has influence, I think is one of the most important elements is that I think thanks to certain software, okay, for 3D modeling, there are new forms and shapes or space making things that can be explored that before couldn't be explored. We have to think that even with the kind of facilities that Luis deals with and Acciona has here in the UAE, this idea of being able to produce on a single piece an element that has concavities and convexities within a single piece, that was something that would be probably absolutely impossible to explore. Okay, and I think of just like an exploration from the design point of view when you are in the speculative process, that would be impossible. And on the other side, I think that the technology is really allowing all of us to really be able to explore and to take much farther new languages. That at the end of the day, I think there was only certain privileged minds in the past. That I'm thinking about Sahadid in the 90s, where actually that kind of geometries was a question of how deep understanding of geometry people had, but I think that has been more democratized, so to say. So I think we're going back to another revolution. It happened with this democratization of the designs and designed goods that happened with the Industrial Revolution. It happens with the arts and crafts, where somehow again there was everything was available for more people. Now I think we all have access to these tools, and I think that there's another even evolution, not just about the 3D printing, but how we can really investigate these forms and shapes. I think that the rendering techniques that now we're moving into software that have real-time rendering, and we have to thank the gaming industry that now is allowing us that we are actually now we can really play with, like we were doing in a gaming software or a gaming process, we can really reproduce certain designs and to see what they look like in real time. And I think that is a very important element. But again, it's a constant catching up and chasing the train of innovations and research. And I think that it's not just the industry or academia. I think that elements like the Research and Innovation Park, I think it's a right platform so everything can merge all together.
Yeah, it's fascinating. I think we all really understand the benefits of 3D printing from a from a times perspective, from an opportunity perspective, from even a waste management perspective, right? Being able to really produce exactly what you want without having excess waste like you do in conventional construction. What are the limitations today that are inhibiting sort of taking that mainstream? Is it an issue of materials adapting to certain environments? Is it the cost of the machines? Is it lack of, what are today the main limitations in 3D printing?
Can I go?
Yeah, of course.
Mm-hmm.
Yeah, let's see, limitations you mentioned and benefits. If we talk about benefits, they are already there and we are exploiting those benefits. I usually think with a powder bed technology that I've been working with, the freedom of shape is a main value of this. The customization, you can produce, all the pieces can be different. You don't need, usually if you work with a mold, apart from the disadvantage that you have with a mold is that you have one mold and you repeat the piece all the time the same. You have that cost of the mold, and you have the waste when you scrap the mold. And the mold, it is not that free to make shapes, okay, different complex shapes. So that's what is as a main value, freedom of shape, okay? So when you go in that way, you mentioned cost, for example. If you compare to traditional methods, you think of the bridge I already showed before. It's a 12-meter long bridge with a really complex shape that if you try to do it with traditional methods, it's going to be almost impossible, or if you can do it, it's going to be quite expensive because of all the extra work that you need. With 3D printing, you're completely free to do that. The complexity doesn't add any cost. So that's the main thing regarding cost. And what's happening with the implementation to make it mainstream? To be honest, the main thing or the most important actions is this kind of action that we are doing here. Webinars, getting aware of the technology everywhere so people understand what is it about, what can be done with the technology, what cannot be done with the technology. So you know what to demand from this technology. So I think in order to make it mainstream, we have to inform, to educate the market, because sometimes, just to make a specific example, during the 3D printing process, you're printing concrete. You're printing concrete. So if you want to add any reinforcement, it's an additional process that can be done, and it's something that has to be solved. We're working on it, but it's something that is kind of extra. In the printing process, you print concrete. So I've heard people requesting a 100% 3D printed, whatever object. And you say, okay, but you know about reinforced concrete? Reinforced concrete was invented because of a reason, because concrete works very well on the compressive strength, but not in tension. And that's why you add the rebars, the steel, just to make a better product combining steel and concrete. And that's reinforced concrete. So when I listen to people asking for, I wanted only 100% 3D printing. So you say only concrete. So it's going to give a lot of limitations because the structural part is going to be quite limited because using only concrete. No one in the construction industry is going to try to do something using only concrete. So just educating the clients and the market is one of the main things that we have to do so they understand and they can request and make it work. I mean, there are many other things, but this is the main that comes to my mind.
Okay, wonderful. Thank you for that. Juan, I don't know if you want to add anything to it,
No,
to that
yeah.
sort of limitations, but it kind of brings me to my next question as well. Other than bringing awareness, it's a great point. Really educating for people to really understand, because it's such a fast moving technology as well that you kind of need to keep up. But what are sort of the main concerns that are inhibiting the regulations from moving fast enough to keep pace with the technology in 3D printing? Because from what I understand today, the regulations is not favorable. By the way, between brackets, from the participant, if anybody has any questions, please send them along to on the Q&A, and then I'll ask the panelists whatever question you have.
Yeah, I think regulation, when you talk about small things or mock-ups, it's hardly a problem. I mean, if a chair, if it breaks,
yeah,
nothing really happens, or not too wrong. When you talk about a building or bigger things, so you have to be 100% sure that it's going to work. Mm-hmm. And of course, it's you have to do all the work on designing and calculation and making all the numbers, but they are usually based on a regulation. So as Juan said, that sometimes academia is like behind when regulation is always behind because they usually try to regulate the new things. So new things come, so they come and regulate. So that's something that they need to catch up, and we at this moment we use existing regulation, but there has to be a particular regulation in terms of at least 3D printing in construction, and I think this applies for any other sector. I don't know. I'm thinking of aeronautical. If you are going to put a piece on a plane, my God, that has to work.
Yeah. So it's kind of a mix of trusting the process and the technology itself, starting with, say, pilots, testing it, making sure it's steady and secure, and perhaps also a mix of sort of seeing what's available and what's going to survive in the market, as in terms of technology, in terms of materials, and whatnot. Do you think that's what it's really related to? Kind of sitting back and before allowing mass deployment?
Yeah, I mean, demonstrators are also one of the best tools to demonstrate that things work. And of course, it usually takes some investment and time, but it's something that we have to do. We have to show that it works.
I would like to really add that I think that question probably wouldn't make any sense some years ago. That I think is fascinating that we can make it now. So when 3D printing, ABS, 3D printers were meant to be only for testing small scale, medium scale size elements. Now that I think that the technology is really allowing that in vivo, that idea of a one-to-one, I think that really opens a fascinating conversation. And again, goes back to this idea of how the regulation is something that it's chasing the industry or the other way around. When we think about probably one of the most specific and most advanced industries, and we think about aerospace or aeronautical technology, I mean, something that has always fascinated me is that if you think about Boeing or Airbus, any piece that leaves that factory has always been tested and retested by the factory itself. So there's no entity outside that is actually somehow in charge of saying, okay, bring the piece, let's try it. Okay, no, whatever they do, is actually goes through the process of their own self-testing. Okay, so, and there's always that somehow that doesn't happen in the construction industry. So there's always this third party that will be in charge of bringing the magnifying lens and to test our things. And again, goes back to an interesting question. Like, it has to do with, on one side, the 3D printing technology, or the state of the art of the technology, and on the other side, we could argue the same things with traditional technologies. Rammed earth is always a problematic issue when it comes to find the right legislation and to find the right protocols to really prove that it works. So I think it's an interesting dialogue between the both extremes of the spectrum in terms of low tech and high tech. Yeah.
Yeah, there has to be some standards that are set up and defined, refined, that everybody needs to follow. Building codes, I mean, it's so complex, really, but really fascinating. I mean, but we are getting a lot of interest. So for instance, at the park, we do have a 3D printed house on our plot that attracts a lot of different parties, private investors, real estate developers, government entities. So hopefully together we can really influence and pioneer that movement and the regulatory changes together. But I think that could be a webinar on its own, but it's really interesting.
Yeah.
And fair enough for the regulations to be sort of, you know, a little bit slower than the technological advancement, because those things
they are working. They are working,
yeah,
but not finished.
Very interesting. I haven't gotten any questions from the attendees, but I wanted to touch base on one last element maybe until someone has a question. What about the materials? What are the challenges there? I mean, I know that there are, you use different, it's a complex element of the 3D printing. There's, you take into account the steadiness, you take into account the environment in which the building is being, a particular thing is being 3D printed. What are the challenges that we're facing today with materials?
The material. Yeah. Juan, do you want to start? Or?
No, please go ahead.
So I usually describe the technology with three pillars. We have the machine itself, the hardware, the machine. We have the software and the way we design, both architectural and calculation. And the third one is the material, and it's a key part. I mean, if you don't have that, you have nothing. So what was our approach in our particular case? We decided to start working with concrete, kind of special concrete, but concrete at the end, because we didn't want to add more uncertainty to the project. Because, okay, we have a new production process, so it's going to be hard to introduce to the general public. So let's work with a kind of traditional material as concrete. So this is what I want to say is that the very important part on the technology. And then a very interesting area to start working and go broader and work with other kind of materials, okay? Maybe light materials, because you can make it lighter if you want, or reuse materials, including some plastics or recycled plastic or whatever, using wood or any waste from other industry. So that's a very interesting part that we are working and we should have some additional solution. But yeah, material is key, and it takes a lot of work to get the right material that works.
I really like to add on that, because I think that's probably the different part between the industry and probably the experimentation that can happen in academia, and I've witnessed some of these not groundbreaking experiments, but somehow things that have really stretch the possibilities of 3D printing. And I was studying at the bottom at the UCL when the traditional 3D printed starch, what do we call this, powder 3D printed, someone thought, why cannot we 3D print with starch and color starch? So, I mean, that is where the first experiments begin to happen. And worldwide, one of the first experiments that happened with this polychromy of 3D printing happened there, because someone decided, okay, it might be worth maybe breaking 3 or 4 of these machines, but at least a try. Okay, the same experiments conducted in SciArc and some other universities have really thought, what if we change starch by, okay, or one of these powder mixtures by a very thin powder of concrete, or thin powder that's made out of stone, limestone. Okay, so there was 3 or 4 attempts, errors, failures, but at the end of the day, there was a prototype of a machine that somehow was able to produce these at a smaller scale. So I think that in both worlds, I think there's this necessity in one side to really that the industry keeps that level of quality of whatever is being produced, and it's probably something more specific, okay, and experimentations in academia or somewhere else, where actually some of these experiments are done in a more crazy manner, to really think about how far they can really be taking. So, but again, it goes to a question of cost, okay, and a balance of the opportunities that you get out of this. But again, if we think about the Bartlett School of Architecture and some of the examples I was giving in my lecture, it has become one of the most advanced laboratories of 3D printing in the world. Because of that, I would say, not because of the amount of choice that they have, but the amount of curiosity that they have in terms of exploring the limits of the technology itself. And again, I would like to really go back to this question that it was going to be one of my final conclusions. It is how we can really elevate the level of awareness and education about the technology, because the more technology that is available for more people, the better advancement and faster advancement that we'll have, even from a very basic question about the interface, how we really communicate with the software and how we communicate with the machine. That is what, at the end of the day, will make another revolution of how the tool itself becomes a democratic element.
Yeah, I want to be mindful of the time. There's one question that just came in for Juan. If we could address that quickly, if that's okay with you. What are the constraints for furnitures and interiors using 3D, if any?
I don't think there are. And I think the only limitations that we have now is about knowing how far you can really take that technology. And again, I was providing the example of the microwave, but I mean, again, for cooking, we need a microwave, we need a good knife, we need a chopping board, we need an oven, or we need a barbecue. And probably in each, for a specific design, we really need to know the balance between not just the ingredients, but also about the tools that we're using. I'm a big fan of exploring different processes, but always being very mindful about what each of them can give me. Again, it's this question that, or these thing that Luis was referring to. What do you want this to be as a 3D printed? Well, actually, you can do it easily just with having a single mold. So I think that knowing which are the possibilities of a tool also will allow you to know which are the potentials, or which way or direction you should take with any of your furniture designs, I think. And again, being specific to the tool is a very important element for a good designer, or for like having a good kitchen, or knowing how to use the right tool or the cutlery for a cook. It's essential. Okay.
Of course.
In my case, there is a kind of funny limitation. If I work with concrete is heavy. So maybe
go pick up that chair.
You have a very nice chair that weighs 200 kilos. So, okay.
That's hilarious. That's actually really true. No, but there are a lot of different, I mean, all the panelists, I want to mention that sorry, panelists and attendees, I want to invite you all to attend our exhibition. We do have a 3D exhibition at the park. It's temporary. It'll end second week of December. So if you want to come by to the park, it's really easy. You could put SRTIP on Google Maps and it takes you straight here. You can come see the exhibition. You can see the types of machines that are there. You can see the types of products that we can print and the evolution of 3D printing and, you know, all the opportunities that it's presenting. It's quite fascinating. So come visit us if you have time, come by. And if you have any questions, unfortunately, we are running out of time. So I won't be able to take on all the questions, but please feel free to reach out to info@srtip.ae. You could say in the notes, you know, want to speak to Jude about the webinar or want to connect with Luis or Juan, and we'll do the necessary. So I want to thank you so much for being with us today. I think that the 3D printing conversation is not going to end today. I think there's a lot more to speak about and a lot more to see and discover. But thank you so much, Luis and Juan, for being with us today. Thank you for your time and for the information that you shared. It's really fascinating, and for the attendees as well to tune in. And if you have any question or any inquiries, anything at all, just feel free to reach out and I'll make sure to attend all of your questions. Thanks again, and see you soon.
Thank you very much.
Yeah.
All right. Have a great rest of the day and week.
Bye.
Bye.
Bye. Thank you.